Saxon's Calculus Lesson 7 is about quadratic equations. Now, they remind us at the beginning of this lesson about some terminology which we stressed a lot in trade class, so you should already know it. But if I just have two parentheses here and I solve and I say that x is -3 and x equals 1, and it doesn't have the or equal to written there, this is a quadratic polynomial, and so we would call those the zeros. If I take the same thing and I set it equal to 0, it's now a quadratic polynomial equation because I set it equal to 0. The same answers of -3 and 1 are now called roots. And finally, if I change this and I say y equals this, then it is a quadratic polynomial function, even though it's equaling y. For a function, it typically would equal f of x or whatever. We call them now the x-intercepts because they are where we cross on the y-axis. That's where we would put our dots. So zeros, roots, and answers and x-intercepts are all basically the same things. Then on the bottom of page 49, they show you the equation of something where it says y equals x squared plus 2x. They said -3, I just wrote +3, it doesn't really matter. When you have a squared and a plain other letter, you're graphing a parabola. And so they show you what happens as they shift it, where they wrote negative or +3 at the end. Where does that shift it? If they have +1, where does that shift it? Well, it's changing where the vertex actually begins, and so it's shifting it right and left. And then there are obviously shifts that can happen up and down as well. So then they move on to example 1 on page 50. Oh, wait, some dark words there at the top of 50. A constant term in the function is whatever is the number in front of the highest exponent. So in this case, it would be a 1. And that is affecting where it crosses the y-axis. And again, you're going to do these the way you've always done them, with graphing them, either picking points and so forth. You're not going to necessarily remember what the constant term does. But hey, if you do and it's helpful, wonderful. And then it does remind that the graph does not touch the x-axis if and only if the zeros of the polynomial are complex conjugates. Complex meaning they actually have i's in them. All right, so now that we've gotten through their words, example 1 says to factor 2x squared plus 3x plus 2 over the set of complex numbers. So this tells me immediately that my answer is not factorable. I'm going to have to do the quadratic formula, and the answer is going to have an I in it because it's complex. So we're going to go ahead and label A is our 2 coming off of x squared, B is our 3 coming off the x, and C is our non-x term, and we're going to put it in the quadratic formula. So -b, -3, plus or minus the square root of b squared, 3 squared is 9, just a second, I wrote plus and I meant minus 4ac, 2 and 2, all over 2 times a. 2 times 2 is 4. So -3 plus and minus the square root of 9 minus 16, all over 4. Keep simplifying. -3 plus and minus the square root of, and then 9 minus 16 is definitely a negative number, -7, and then over 4. So the last part that I can actually simplify is to say -3 plus and minus, and pull the negative out as an I, keeping the root 7 over the 4. And the numbers 3, 1, and 4 are not reducible. So these are the two answers. Now they chose to put them back in a parenthesis and say that it is x, and of course when you go into a parenthesis you're changing the signs. So x plus 3, and then if I do the positive version, plus I root 7 all over 4, multiplying with x plus 3 minus the I root 7 all over the 4. And they're saying these are the two, that kind of looks like it's up at the top. It's meant to be like here in the middle, x plus that fraction. So that's what they're writing. Oh, and again, their I is at the end of their root. I am happy with answers just boxed this way. This just looks more complicated again, but just know that the answer can be shoved back into its parentheses. All right, example 2. Graph the parabola for f of x equals negative 2x squared minus 8x minus 5. So for graphing, since I know it's a parabola, it told me that. I also know it's a parabola because I have an x squared and a non-xed term. And so I'm going to need to complete the square in order to get this into a format where I can be pulling the vertex point. So let's move the 5 over, temporarily putting it over here with the equal, and then pull out the negative 2, leaving the x squared plus 4x, and then equal, keep my negative 2. Now I'm going to follow the complete the square steps where I write half of my x term is 2, 2 squared is 4, 4 times negative 2 is negative 8, adding that with the other side, so negative 3, and then I put that back over here as a positive 3, and I can go back now to my f of x equals this. So my vertex point is going to be negative 2 because I'm pulling it out of the parenthesis, and the positive 3. So negative 2, positive 3, vertex point. I know that it's opening downward because this is a negative, and so I'm going to grab 0 as the easiest point to plug in. 0 plus 2 is 2. 2 squared is 4. 4 times negative 2, negative 8 plus 3, negative 5. So 0 graphs, 1, 2, 3, 4, negative 5. And we remember that the vertex point is mirror imaged with everything else. So this was 2 jumps away at negative 5. So let's go to the other direction and match the same negative 5. And here is my graphed parabola opening. Oops, I missed the dot. Going down. Now, example 3. Find the quadratic function whose roots are, so they're giving me the answer and asking me to work backwards, whose roots are, actually didn't say roots, zeros are, but again, it's same thing. So I'm going to put it back in a parenthesis, and it was minus 3, so we're going to write plus 3. And then the other is x, and it was plus 2, so we're going to write minus 2. And whose y-intercept is 3. All right, I'm going to come back to that part. I know that these may be the answers, and I'm going to distribute and see what I get here. But there could be other numbers that have multiplied in front, like an extra constant. Just like I had that negative 2 that I had to factor out in the example from before, there could be other numbers embedded in here. But let me go ahead and start with getting us to our distributed x squared minus 2x plus 3x minus 6. And then like terms go together, x squared plus x minus 6. Now I can go back and look for that extra potential coefficient where it said the y-intercept was 3. So if the y-intercept is 3, that's implying that my x is a 0. So then if I plug that in, I'm basically saying 3 equals what constant is multiplying with all of this is basically what I'm asking. And so 0 and 0 drop off, and this just leaves me with, if I plug those in, a minus 6. So what could my constant be that would turn negative 6 into 3? Well, that would mean a negative number, because negative times negative would be positive, and I'm going down from 6 to 3, so that's a half. So now I know what my constant is. I need to put it back into the problem. So y equals negative 1/2, and then distribute that out with the x squared, with the x, so negative 1/2 x, and then that turns it into positive 3, just as we knew it would. And find the quadratic function whose, I just did that, then graph the function. Okay, so this is the actual formula. However, I'm not in graphable format, so I would technically need to complete the square like we did for the last problem. Although I'm wondering if I can shortcut with the -3 and the 2. I think I will. We know that the x-axis numbers we're going to be crossing at -3 and at 2. And I know that this is a parabola because I've got the squared and the non-squared. And so the vertex point should fall somewhere in between these two. In fact, it should fall in the middle of. So how many spaces is this? 1, 2, 3, 4, 5. Okay, so it'd be like 2 and a partial. So 2.5 needs an answer somewhere here to be the vertex. And I'm just sort of putting it there for the moment. I know that this is opening downward because of the negative. And I know that the half tells me it should be fairly wide. But I really should figure out more precisely where it goes. So I would actually, rather than completing the square, which can be complicated, especially with these fractions, I would go ahead and plug in that -1/2 and see what it gives me for the vertex point. All right, so 1/2 squares 1/4, -1/8, multiplying it, positive 1/4 plus 3. Common denominator should be 8. -1 plus 2, 1/8. 1/8 plus the 3, that's 3 and an 1/8. I might just do it that way. 1, 2, 3, and a smidge. Oh, I wasn't too far off. And then I can graph, can graph the parabola that way, without having to complete the square, or I could have completed the square, found the vertex point that way, and then also use those 2 points.